Minecraft is trending a lot lately. Mostly because of that disappointing trailer they released of the Minecraft movie, but that made me wonder something. What would Minecraft look like? And unfortunately, since I don't make movies, I can't possibly remake the Minecraft movie, but you read the title. Trust me, you're not going to want to miss this. First off, I opened Roblox Studio and created a new file. After some moments of uncertainty, unsure how I should begin, I hopped on Google for some needed inspiration. More importantly, I wanted to get an idea of how Minecraft looked. Now that I'm fully inspired, I decided to start off by experimenting with the size of the blocks that will be in the world. In Minecraft, the size of the block of a single block is 1 meter high, which when converted to studs, Roblox's measurement system is 20 studs exactly. The average Roblox avatar height is about 5 studs tall, according to Google that is, and this is why I have to size the blocks compared to the Roblox avatar height. For the time being, I settled on 2.5 meters for the size of the blocks. This will later be changed to 3 meters for reasons you'll learn later in the video. Currently, we have a single block in the world, but it's quite boring to look at. Speaking of blocks, I think it's only fitting to begin working on textures. For the moment, I'll start off with a grass block texture. Each side of a grass block has a somewhat unique design, and to save time, I'll source the textures from Google. Luckily, I found an image that had all the textures I needed for the grass block, so using Krita, I resized the image and separated it into different textures. Afterwards, I uploaded them to Roblox as decals that I could then use in the game. The textures alone worked well in the game, but to my total surprise, when 2 or more were put closely together, these bothersome lines would appear between the blocks, even when the blocks were overlapping. For the longest time, I couldn't debug the problem and considered giving up, claiming this is an unsolvable bug that's solely Roblox's fault. Yet, I wanted to try one more time. Maybe it's a problem with the textures, I wondered. So, after rigorous Google searches later, looking for better textures, I found some and did the whole process of resizing them in Krita and importing them into Roblox another go. But, to my dismay, all this attempt succeeded in doing was improving the look of the textures, but not solving the problem at hand. In the meantime, I decided to move on to a different task. The next task was terrain generation, and as luck would have it, I've made something similar in another project of mine. So I'll just ignorantly copy that code from that and paste it in. And almost like instant karma, I had completely forgotten how the code worked and was completely clueless for a great deal of time. Talk about irony. Luckily, again, I've done this sort of thing before, the same project from earlier, and after yet another copy and paste job, it's in the game. To test that it worked properly, I inputted many different numbers to see the outcome, and they all seem to be alright, one of them being 10,000, but that's all besides the point. I need to find a good enough number that's even on all sides when placed flat. In the end, 361 blocks was the chosen one. Looking back, I could have just did 19 times 19, and that would have led me to having both 19 blocks on all sides and 361 blocks in total. This is what I did in the future, so there's that. With that done, I think it's time we try and tackle the problem with the textures again. First, I started by putting up a way to apply textures to the blocks in the world. This didn't take long at all, but the pesky line showed up yet again, taunting me. To try and finally combat this problem, I tried various fixes including overlapping the blocks, increasing the sizes of the textures, and lastly, making the blocks transparent. This solution fixed the problem, but caused yet another. Since the last attempt did fix the problem, I thought of ways to fix the other problem it caused and considered replacing the textures with decals, but to no avail. This is the frustrating thing about debugging. You may fix one problem, but cause another. But funny enough, this helped me actually diagnose the true problem and find the proper fix for it. Let me explain. I've applied textures to all the blocks on all their faces, front, back, left, right, top, bottom, but many of them are overlapping due to the game not knowing which to overlay and which to not. The fix to this is what games commonly do, including Minecraft, which says a lot. Maybe, just maybe, I should have researched this problem more beforehand. The solution is simple in my case. Code up a function that loops through all the blocks and checks those nearby. For example, we have a block, we can check to see if a block is in front of it by raycast, and if a block is indeed found, we disable the front texture. Easier said than done. It took quite a bit of playtesting, surfing through the Roblox documentation, and confused Google searches later to get it to work properly. In the end, this was the result. And that marks the end of day 1. Moving on to day 2, for the entire day I didn't work on anything and skipped development altogether. Today happened to be my birthday, hence why there's no footage and no progress made. I did, however, have some delicious Chipotle dinner. That's it for day 2. I hope I don't skip any more days of development or I'm going to fail the challenge miserably. Today, I want to focus on that block generation code we made yesterday. Currently, we're generating a grid of blocks, sort of like a chunk, you could say. I want to make it so more can be added into the world. To do that, first I need to find the midpoint of the chunk. This will be important later. By using the first and last block positions of the chunk, I can estimate the midpoint using some trickery math, and by that I mean adding both positions and dividing them by 2. Due to me not understanding math, I did have one hookup along the way. Thankfully, that was patched quickly. Alongside that, I struggled with deciding how the player would spawn into the world. First, considered spawning them in a temporary location and teleporting them to the terrain once it was finished generating, but in the end settled on the default Roblox spawn point part that has the added benefit of no extra work needed from me. The key benefit to a chunk loading/unloading system like this is primarily performance. Unloading chunks that aren't nearby saves processing power, but presently so we're lacking in this capability. To curb that, I created a new local script that'll handle everything. Simply put, we loop through all the chunks, check their distance from the player using the midpoints we created earlier, and if the distance is below a specified threshold, we load them in, and so on and so forth. My coding ability doesn't come without its trials and tribulations though, like forgetting to set the chunk's primarily part to its midpoint, and trying to raycast even though the object isn't in workspace, thereby completely nullifying my raycast system unintentionally. I learned that last one the hard way. It's interesting to see the outcomes of my failures, but nothing beats seeing code actually work and the final product successfully come out as a result. To my worry, I couldn't help but time and time again break the raycasting system, and in doing so resurfaced the overlapping textures issue from earlier that we solved, but I guess I was in a changeful mood that day too, because for starters, I was testing different block sizes, trying to find the one that would fit into the game better, but also short enough to jump over. I considered the idea of making the player's avatar Minecraft Steve, but ultimately threw out the idea of Steve because the game would solely take place in first person and you wouldn't see it. Lastly, I increased the block size to 3 meters, which is just shy away from the previous size of 2.5 meters. At this point in development, I thought it'd be a fitting time to start thinking how we'll go about spawning the trees in the world along with their overall design of them. Personally, I planned on designing 3 distinctively different tree models, but settled on just one for simplicity's sake. Thus, with the tree model fully mocked up, I then programmed the spawning functionality. It'll look something like this. After the terrain chunks are fully generated, the tree model will be repetitively cloned and positioned within a randomly selected chunk. The chance that a tree will spawn can be modified by increasing or decreasing the tree spawn chance value. And with that marks the end of day 3. Today is the day, my friend. Today we finally get to more compelling stuff. I'm talking about block placing. It's an essential part of Minecraft. I've never made a block placing system before, so the future is filled with uncertainty, but I digress. To start off, I took some code from our previous project and pasted it into this project. 90% of this project is just me stealing code from my prior projects, I swear. With some minor tweaks, it was already working how I wanted it to. Although, there were several instances where the mouse was targeting things that weren't blocks, such as my character. I didn't want that to be targeted, so I had to find and carry through workarounds for that issue. More importantly, I was completely lost and doubtful how I was going to program the actual block placing. There was a lingering problem on my mind. If the player clicks to place a block on top of that block, then subsequently a new block will be placed on top of that block. But stay with me. Not on either of the sides, not below, but depending on the face the mouse clicked on that original block. Hopefully that makes sense. I need to somehow hack it so when a block is placed, it's positioned properly. This will include finding out the normal of the ray and some adequate understanding of math. On a completely different note, I took a considerable length of time experimenting with ways to make the terrain less flat by tinkering with the block generation code, randomizing block Y positions, and lastly adding some variation and chance to the terrain. But none of these really sticks like how I wanted it, so the ideas are put on the back burner. But getting back on track, along with many headaches later, my first test at trying out block placing went quite successful, showing that maybe I'm not so trash at this after all. But there is a major issue yet to be addressed. Currently, whenever a block is placed or destroyed, I'm reloading the entire chunk, which is, as you probably imagine, isn't at all efficient in the slightest. So instead, I will only update the blocks touching the block's faces, which will drastically improve performance. I can hear my computer already thanking me. Earlier, I put some ideas I had for the terrain on the back burner. Now I want to see if I can get any of them to work. First, I tried out a layers concept. The bottommost layer would have the most blocks, while the topmost layer would have the fewest blocks, but the result was too scattered and resulted in the terrain looking too unnatural. To try and thwart that underwhelming outcome, I attempted to change the values, but this was also to no avail. Somehow, doing all that, I broke the terrain generation, and as a result got a completely different outcome. It looks almost like a maze, except it has no start or end. Later, due to the subnormal results, I decided to call it and stick with the flat terrain. Shortly after, I played the game, built a dirt hut for myself, and tested the game's limits, which you'll see for yourself wasn't very far. I had way too much fun fiddling around in this world. If you're enjoying the video so far, why not hit that subscribe button? It's free. Plus, if you do, Dandy won't. And that concludes day 4. It's day 5, and I'm tired of working on terrain. I want to do something different. Today, we'll be adding an inventory to the game. Not a full inventory though, just the 9 hotbar slots. Each slot will contain a different block that when equipped, you can place into the world. First off, I started by browsing Google for a hotbar slot PNG. I'm sure you know the deal by now. Afterwards, I had difficulty with the look of the hotbar slots, but just kept at it, tweaking it again and again. For the block icons in the slots, I decided to use viewport frames, which offer a way to display 3D objects in a 2D space, as Roblox puts it. Very finicky, I must say. So much adjusting, rotating, and debugging. Once I was done positioning the block in the viewport frame, I added the 8 other blocks, including stone, dirt, oak wood, oak log, cobblestone, sand, brick, and lastly, oak leaves. That was a tongueful. Afterwards, I stress tested the game to the best of my ability and noticed no glaring game-breaking bugs or anything wrong in particular. I believe the game is coming along nicely. To finish up the day, I decided to create a loading screen. I grappled with the idea of a dirt image as the background, but settled on a solid color in the end. I made it so the loading screen doesn't go away until the terrain is completely loaded, waiting until the game is finished loading before the player is able to play. Amongst all the blocks in the hotbar, sand is the most unique out of them all. That's because in Minecraft it has a striking property different from the rest, and that's it's somewhat affected by gravity. In they attempt to replicate this effect, I achieved some success but shelved the idea. The image of floating sand in my head looks extremely surreal to me, so I intentionally decided to keep it. Maybe it'll disturb some of you. I didn't work on the game for 2 days. In theory, you could say I failed the challenge because I went further than 1 week, 8 days in total, but honestly I'm excused because my birthday was smack dab in the middle of it. But also, on the contrary, I'd say I succeeded altogether. I was able to create Minecraft in those 7 days. As for today, I'll be primarily polishing the game, refactoring the code, diagnosing problems, bug fixing, and improving performance. We can all mutually agree this day doesn't count. Here are some noteworthy mentions though. Firstly, I fixed duplicate blocks. Sometimes when trees were spawned closer together, leaf blocks would be created in the same position, thereby having 2 duplicate blocks occupy the same single space, which is a no-no, aka performance nightmare. Secondly, I greatly reduced the terrain generation speed. What took seconds to complete now takes milliseconds thanks to some needed optimizations I did within the code. Thirdly, the game now keeps better track of what chunk to set the block to. Now it tracks which chunk the player entered most recently, and if you place a block, it is assigned to that chunk. Unfortunately, this solution isn't bug-proof, but is significantly more efficient when compared to before. To complete the game, we must finally tackle the last remaining task, graphics. There's a reason I saved this part for last. Luckily, it won't be stressful as demanding as the prior task. Firstly, I added fog so unloaded chunks aren't as visible and apparent. Secondly, I adjusted many of the lighting settings and even made the grass block texture darker to give the world a better contrast. Previously, the leaf and grass blocks were too similar in color, which resulted in them blending in with one another. Thirdly, I added some post-processing. Most importantly, I added sun rays and a Minecraft sky from the toolbox. With all that said and everything said and done, it's time I show you the final creation. We're almost at 1,000 subscribers, and it'll help me a ton if you went down below and quickly hit that subscribe button. At 1,000 subscribers, I will turn on my webcam and reveal my face. More videos like this coming, so stay tuned. I promise you won't regret it. See ya.